Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is range of a function. In our previous video, we discussed about the domain. Now let's see what is range. When functions are first introduced, you will probably have some simplistic functions and relations to deal with. Usually being just set of points, these won't be terribly useful or interesting functions and relations, but your text wants you to get the idea of what the domain and range of a function are. Small sets of points are generally the simplest sorts of relations. Okay, I'm going to start. Do you see the question? You're given a set of ordered pairs. So how do we find the domain for this? Here we have a list of points being a relationship between certain x and certain y's. That is called a relation. So domain is nothing but all the x values. So the range is all the y values, the second coordinate in each of the ordered pair. So how do you give your result? It is customary to list these values in numerical order, but it is not required. Sets are called unordered list, so you can list the numbers in any order you feel like. Just don't duplicate. Technically, repetitions are okay in sets, but most instructors would count off for this. So it is better to avoid repetition. So range for this set of orders is -3, 6, -1, 6 and 3. I have avoided repetition. While the given set does indeed represent a relation because x's and y's are being related to each other, the set they gave me contains 2 points with the same value, 2, -3 and 2, 3. Am I right? Since x is equal to 2 gives me 2 possible destinations, that is 2 possible y values. 2 is related to -2, -3 as well as +3. Am I right? Then this relation is not a function. So this is how you have to find whether the relation is a function or not. So that's it for this problem. Please note that all I had to do check whether the relation was a function was to look for duplicate x values. So if you find any duplicate x values, then the different y values mean that you do not have a function. Please remember that for a relation to be a function, each x value has to go one and only y value. Hope you're clear with this problem. This is another example of the same boring function. Just like the previous example, every last x value goes to the exact same value. But each x value is different. So this relation is indeed a function. Does this make sense to you? They are all different x values. So in point of fact, these points lie on a horizontal line y equal to 5. So what should be the range for this one? 5, 5, 5, 5, 5. We need not repeat. So the range is just 5. By the way, the name for a set with only one element in it, like the range set in this one, is called singleton. So the range could also be stated as singleton of 5. Both are same. Hope you're clear with this example. There is one other case for finding the range of the function. They will give you a function and ask you to find the domain. I have only ever seen 2 things at this stage in your mathematical career that you'll have to check in order to determine the domain of a function they'll give you, and those things are denominators and square roots. So I'm going to take examples where a function is a rational function as well as a square root. Okay, let me take those examples. So to find the range for this example, I have to remind you how to find the domain. Domain is all the values that x is allowed to take on. The only problem with this function is that we need to be careful not to divide by 0. So the only values of x cannot take on are those which would cause division by 0. So you can set the denominator equal to 0 and solve. If you solve, you will get x is equal to 2 and -1. So the domain for this function is real number excluding -1 and 2. Now let us find the range. Range for this function is a bit trickier, which is why they may not ask for it. For these types of problems, they may not ask the range for you. In case if they are asking, they will just give you a graph. In general, they will want you to graph the function and find the range from the picture. Let me post the graph of this function. So here is the graph of the function. As you can see from this picture, the graph covers all the y values. That is, the graph will go as low as I like. and will also go as high as it likes. So for any point on the y-axis, no matter how high up or low down, we can go from the point either to the right or to the left, and eventually we'll cross the graph, since the graph will eventually cover all possible values of y. So what should be the range? The range is all real numbers for this example. Does this make sense to you? So when it comes to a rational function, you better graph it and look for the ranges. Ranges, you have to concentrate only on the y values. Okay, now let me take one example which has a square root. Here is the next example. So when we get a square root, we should know that a negative inside the square root cannot have a negative. I mean, the function under the square root cannot have a negative. Okay, so we need not worry about the domain, because we already have learned how to find the domain for a square root function. Now let's see range. Range requires a graph, so we need to be careful when graphing radicals. Here is the graph of this function. The graph starts at y equal to 0 and goes down, I mean heading to the left from there. While graph goes down very slowly, we know that eventually we can go as low as we like by picking an x that is sufficiently big. Also, with graphing, we know that the graph will never start coming back up. Therefore, the range is all y less than or equal to 0. Am I right? So whenever you're dealing with the range, it is better to graph the function. So for this example, range is all y less than or equal to 0. Okay, let us move on to the next example. Here is the next example. This is just a garden variety polynomial, and there are no denominators, so no division by 0 problems, and we don't have any radicals, so no square root of a negative problems. There are no problems with the polynomial. There are no values that I can't plug in for x. Am I right? So when I have a polynomial, the answer for the domain is always all the real numbers or all x. Now the problem is with the range. As we did in the previous examples, here also we need the graph. The range will vary from polynomial to polynomial, and they probably won't even ask, but when they do, we look at the picture. The graph goes only as high as y equal to 4, but it will go as low as we like. So it will extend until the infinity. So the range is all y which is less than or equal to 4. Am I right? So if you're dealing with the range, you should know the graph of the function. After finding the graph, you have to find all the set of y values that satisfies. So this is how we find the range for different functions. As we said, functions have inputs and outputs. The inputs are what we put in the function, and the outputs are what come out. We call the set of outputs of a function as the range of the function. For example, consider a function defined by the rule that we take as an input and raised it to the third power. It can be represented in the equation as y equal to x cube. So for this one, when this function is given input values -2, -1, 0, 1, 2, we can find the corresponding outputs by plugging in those inputs for the x in this equation. Am I right? For example, if you input -2, -2 the whole cube is -8. Am I right? So when the input is -2, output is -8. So -8 is our range. When we find each of the corresponding outputs to our inputs, we have our range. So for this one, the outputs would be -8, -1, 0, 1 and 8, because these are the outputs corresponding to -2, -1, 0, 1 and 2 respectively. So how do we find the range? To find the range of a function, we simply need to find the function's output based on its input. So as we mentioned, functions can be represented in different ways. So I have shown you some examples. Even you may get word problems. Please read this example. So let us consider our initial drink menu example. We described this function using words. The function's rule assign a small drink to $1.50 and medium drink to 2.50 and a large drink to 3.50. The inputs are the drink size and the outputs are the drink price. So the range of this function is the set of all outputs. Therefore, the range for this function is the set of all outputs or 1.50, 2.50 and 3.50. That's it for this example. So no problem even if you get the word problem. You just have to look over the question at least for twice, and then you can take down all the outputs. So the outputs are called the ranges. So it purely depends upon the problem. If it is a square root or a rational function or any polynomial function, all you have to do is draw the graph, and then easily you can find the range. So that's it for the range of a function. In case if you have any query, please let me know. Thanks for watching. See you in the next video. Have a great